What do you mean by virtual work is the term virtual states that it is not real. Real in the sense it is an imaginary force, imaginary work or force. Why they call it as work is if we are doing anything in this world, it is quantified as work. How much force is different, and the work is a quantifiable matter. So whatever thing you are doing, it can be quantified. See, if you are moving any rock, if you are moving a 100 kg rock from 0 meter to 3 meter, it is called as work. What is the formula for work? Work has some formula. Force into distance. So how many meter of distance you have moved? The same example you can take. The 100 kg of a rock, you are pushing the rock to 5 meter distance in how many seconds, in how many hours, which counts your work. If a small person is there, or 10 or 15 kg person, they cannot complete the work. They cannot move the 100 kg of rock to the destination. If you are a 100 kg person, you can do it at different level. If you are using any JCB, it can be done at very easy mode. So this quantifies the work. Who is doing work, how the works are done is being quantified by this formula. So the work formula is force into distance. If you are moving more distance, then what is the understanding is more work is being done. If 100 bricks are being transferred to the 7th floor, then that work is being done and you will pay for the labor. So the work can be quantified. And what do you mean by virtual work is it is not a real rock or real force, imaginative force. If you are applying any imaginative force, this is known as the concept of virtual work. The term virtual and work holds this sentence. Okay. It can be defined as the work done by the external force equal to the internal force. Whatever work done externally, which will same be happened internally. If I am pushing this wall, if I am trying to push this, I will be applying some force. The force is being taken internally by this wall. Whatever force I am giving, it is taken internally. So all the external force, if any object is receiving, it affects the internal particles of that object. External force will always be equal to the internal force. This is known as principle of virtual work. You can take method of plastic analysis. How to find the collapse load. Here in this problem you will be finding at what load your structure will collapse. You can tell it. If any beam is there, you can find that at this load, if it reaches, your beam will get hinges and it will get collapsed. So by this picture you can understand that. Here you have a simply supported beam. This is supported at the two end and you have been loaded at the center. Okay. When the load is constantly increasing, what happens? It goes beyond elastic limit and reaches the plastic limit. This is the point of hinge where you can see that, yes, here is the point of hinge where it is going to get collapsed. What do you mean by hinges? Hinge is a place where you can find that at that place only the collapse is going to happen. So wherever you have a load, you will be having a hinge. In the previous class I have given a note where you will be finding the hinge at the places where you have load, at the places where you have supports, will be having the hinges. So do you have that notes? You can please refer it again. What is the reason or what is the use of finding hinges? Wherever you have hinge, at that place the member is going to get broken. Okay. For finding the plastic analysis, that is the hinge, you have two methods. What are they? Static method and kinematic method. By these two methods you can find the collapse load. This works under the theorem of upper and lower bound theorems. So you have two number of theorems which has been already discussed, that are upper and lower bound theorem. By these two theorem, these two methods are being derived. and you can solve the problem by these two methods. Here you can see the collapse mechanism is created at the point where you have been loaded, and after the element is broken, you can see that it is splitted into two halves. The mechanism is created at this point, and this is known as plastic collapse load. What do you mean by collapse load? In short, is the minimum load at which the collapse will occur. Now we have seen there are two methods of plastic analysis. One is static method and another one is kinematic method. Now let us see kinematic method. It is otherwise known as virtual work method. In this method you can find the hinges. See, the plastic method is generally used for finding the collapse load. The collapse load depends on the hinges. How to find hinge? That is the key point here. How to find hinges? This is the formula, n equal to h minus r. What do you mean by n? Number of independent mechanism. N is known as number of independent mechanism and h is number of plastic hinge locations, which I have given notes that wherever you have negative moment you will be having hinge, wherever you have load you will be having hinges. So these points you should take, and number of degree of redundancy of the frame. So what is the degree of redundancy? How to find that? Redundancy can be found out by number of supports minus 3, isn't it? You have already studied that. R equal to number of supports minus 3. What is that 3? Number of equilibrium equation. Why they are saying this as a kinematic method is they are measuring in terms of load and distance. If any object is moving, then it is known as kinematic. If the object is not moving, it is not known as kinematic, it is said as static. Here the object is assumed to be moved for a particular distance. Hence this method is called as kinematic method. Okay, now take down static method, or otherwise it could be called as equilibrium method. Here they will be using moment at any section is less than or equal to plastic moment capacity. They will be finding the moment, and if the moment is less than or equal to plastic moment capacity, that is MP. If your moment is less than MP, then you can find the collapse load. So this comes under lower bound solution, that is lower bound theorem. So kinematic method is upper bound theorem. You can have a note in kinematic method, that is upper bound theorem, this is lower bound theorem. This is often used to its simplicity of application in comparison with equilibrium method. So we will be using the virtual work method only for the problems. Find out the collapse load for the simply supported beam. Here you have a beam, and this beam is supported by a simply support, and you have a load which is W, subjected to a concentrated load at midspan. Hence it can be taken as L by 2 and L by 2. What you have to find is when this beam will be having collapse load, at what is the quantity of the collapse load, you have to find that. So what is the formula for having a simply supported beam carries point load? What is the formula for bending moment? WL by 4. So you will be getting bending moment. How will you calculate the load? If bending moment is given, how will you calculate load? So you have to cross multiply what? You write it M equal to WL by 4. WL by 4. This is your formula. I need W. You have M. How will you find that? 4M by L. This is your formula. This bending moment is for elastic or plastic section. WL by 4 is, this formula is for elastic range or plastic range? Elastic range only. Currently you are studying for plastic level. You can find the load up to what limit it can take, and what will be the moment you can find out by using the formula. But here you are going to find that at what load this will be getting plastic movement. This is beyond the elastic stage. For that, you will be using, what are the techniques you have as per previous slide? Static method and kinematic method. You will be using kinematic method here. It will be otherwise called as virtual work method. So, what is work? I have said that load into distance. This is the formula for work. Okay. If I am taking this load, I will be getting the bending moment like this, yes or no? If you are drawing the bending moment, for a point load you will be having a straight line, and you can find it by using WL by 4. This formula you are knowing. Here a bending moment is being drawn here. This is the bending moment of collapse. Okay. Now, if you are loading this beam, if it is bending, and imagine that this is the total deflection at the plastic hinge. So, why we are saying it as virtual work is, you have to imagine that this beam is bending at a particular point, it creates a hinge. After the hinge it is going to break. This is the hinge where it is identified here. So, during a breaking point, this will be having a mechanism. What I mean by mechanism is, initially the beam is like this. When it is breaking, it was being deflected to this distance. What is the distance? You are going to find. Okay, if it is moving towards a distance, will you be having any rotation here? Yes or no? You will be having rotation at the support. Here you will be having some rotation. Let us assume this rotation as theta. You will be getting the same theta here. Why? Because this load is exactly acting at which point? Center. If it is not acting at the center, you will be having theta, and theta will be different at the other end, yes or no? Since it is acting at the center, you will be having same thetas at both the sides. So, this is a geometrical property. If you have both the sides are theta here, you can extend a tangent. So, if you extend, this angle will be theta plus theta. This is a geometrical property. So, you can note that. How to find this angle? This is theta plus theta. Okay. Now, you know that what is virtual work is, external work done equals internal work done. Okay. What is external work done is, this is the external load which is applied is W. How much distance the beam is moving? Beam is moving towards this distance. This is the displacement or deflection. How to find this distance? You can take this as a triangle. This triangle, you can assume that what is the length of this triangle? L by 2, and you have the angle. You have to find this distance. How to find this distance? You take it as delta. You assume this distance as delta, and you can use tan theta. That is opposite side by adjacent. Opposite is delta and adjacent is L by 2. Okay. Now, see, this is the exact beam distance. This beam is around 8 to 9 meters. Imagine that how much of the deflection will be there in your beam before collapse. By your imagination, you tell me how much mm it can displace. Can it displace for 2 feet? Can it displace for 2 feet and then break? No, it cannot take 2 feet. So, can you imagine 1 feet? Yes. How? How you are deciding? There is a property called ductility. What do you mean by ductility? Ability to elongate. Steel elongates up to how much percentage? This is why I have given in earlier class that elongation of steel is how much percentage? How much? 30%. Around 30 you are having. Since theta will be very small, the beam is very large, the deflection will be very small, very less. When compared to the length, the deflection will be very less. Hence, you can neglect the tan theta and you can take it as L by 2 into theta. If I cross multiply, so what will I get? Delta equal to L by 2 into tan theta. Since theta is very small, you can neglect tan. So if you apply a value for tan 0.1, what is the value for tan 0.1? 0.001. That is why I am saying if tan is very small, its value is very small. That is why you can cancel tan theta. If you are putting tan 15 degree, what will be your answer? 0.2. At least you are getting some real value. If tan is very less, your value will be very less. Hence you can neglect the tan here. That is why they are neglecting the tan. So theta equal to delta by L. They have removed tan. Okay, if you need delta, you can just add theta into L by 2. Okay, now this is your distance. How to find the work? Force into distance. What is your distance? Distance is theta L by 2. Theta L by 2 is here. What is your force? WU. So this is your work done by the load. That is external work done is W into theta L by 2. Okay, what is internal work done? Internal work is the plastic hinge which is formed. In a beam, where are the points you will be having a hinge? I have given the notes, refer that. At loads. So if you are having any load, you will be having the hinge at this point. If you are having simply supported end, will you have the plastic hinge? Refer that. No, for a simply supported end you will not have hinge. Only for fixed end you will be having. So hence there is no hinge here and no hinge here. So you only have one MP, since there is a load here, and hence you will be having only 1 MP, and this is 1 MP is written. So what is the rotation? Total rotation of this MP? Theta plus theta, that is 2 theta. So the internal work done is, work done by plastic hinge is 2 MP theta. Can you equate these two? So what is the theory? You can equate internal and external work done. What is your value? 2 MP theta equal to WU theta L by 2. What do you need here? Collapse load. What do you mean by collapse load? WU. That is ultimate load. U is ultimate, W is load. How to find that? Take rest of the things outside, you will be getting answer. 4 MP by L. This will be your answer. When will this beam exactly break? At the 4 times of MP by L. How will you find MP? Plastic moment. Do you have any formula for MP? MP equal to Fy into ZP.